guys, welcome to Matsi with me, Miss Resi, your teacher for today. So today we're going to talk about why study physics. Physics is the branch of science that describes matter, energy, space, and time at the most fundamental level. Whether you are planning to study biology, architecture, medicine, music, chemistry, or art, some principles of physics are relevant to your field. Physicists look for patterns in the physical phenomena that occurs in the universe. They try to explain what is happening and they perform experiments to see if the proposed explanation is valid. The goal is to find the most basic laws that describe the universe and to formulate those laws in the most precise way possible. The study of physics is valuable for several reasons. Since physics describes matter and its basic interaction, all natural sciences are built on a foundation of the laws of physics. Understanding of chemistry requires a knowledge of physics of atoms. A full understanding of biological process in the turn is based on the underlying principles of physics and chemistry. The study of natural philosophy encompasses what later became the separate fields of biology, chemistry, geology, astronomy, and physics. Today, there are scientists who call themselves biophysicists, chemical physicists, astrophysicists, and geophysicists, demonstrating how thoroughly the sciences are intertwined. In today's technological world, many important devices can be understood correctly only with the knowledge of underlying physics. In the world, think of laser surgery, magnetic resonance imaging, instant read thermometers, X-ray imaging, radioactive tracers, heart catheterization, sonograms, pacemaker, microsurgery guided by optical fibers, ultrasonic dental drills, and radiation therapy. By studying physics, you acquire skills that are useful in other disciplines. These include thinking logically and analytically, solving problems, making simplifying assumptions, constructing mathematical models, using valid approximation, and making precise definitions. Society's resources are limited, so it is important to use them beneficial ways and not squander them on scientifically impossible projects. Political leaders and the voting public are too often led astray by lacking of understanding of scientific principles. Supply energy safely to a community. What is the truth about global climate change, the ozone hole, and the danger of radon in the home? By studying physics, you learn some of the basic scientific principles and acquire some of the intellectual skills necessary to ask probing questions and to formulate informed opinions on these important matters. Finally, by studying physics, we hope that you develop a sense of the beauty of the fundamental laws that describe the universe. Talking physics. Some of the words used in physics are familiar from everyday speech. This familiarity can be misleading. However, since the scientific definition of a word may differ considerably from its common meaning. In physics, words must be precisely defined so that anyone reading a scientific paper or listening to a science lecture, understand exactly what is meant. Some of the basic defined quantities, whose name are also words used in everyday speech, include time, length, force, velocity, acceleration, mass, energy, momentum, and temperature. In everyday language, speed and velocity are synonyms. In physics, there is an important distinction between the two. In physics, velocity includes the direction of the motion as well as the distance traveled per unit time. When a moving object changes direction, its velocity changes even though its speed may not have changed. Confusing the scientific definition of velocity with its everyday meaning will prevent a correct understanding of some of the basic laws of physics and will lead to incorrect answers. Mass, as used in everyday language, has several different meanings. Sometimes mass and weight are used interchangeably. In physics, mass and weight are not interchangeable. Mass is a measure of inertia and the tendency of an object at rest to remain at rest, or if moving, to continue moving with the same velocity. Weight, on the other hand, is a measure of the gravitational pull of an object. There are two important reasons for the way in which we define physical quantities. First, physics is an experimental science. Must be stated unambiguously so that other scientists can perform similar experiments and compare the results. Must be defined precisely to enable experimental measurements to be uniform no matter where they are made. Physics is a mathematical science. We use mathematics to quantify the relationships among physical quantities. It can be expressed mathematically only if the quantities being investigated have precise definitions. The use of mathematics. A working knowledge of algebra, trigonometry, and geometry is essential to the study of introductory physics. If you know that your mathematics background is shaky, you might want to test your mastery by doing some problems from a math textbook. You may find it useful to visit www.mhhe.com to explore the SHAM Outline series, especially the SHAM Outlines of Precalculus, College Physics, or Physics for Pre-Med, Biology, and Allied Health students. Mathematical equations are shortcuts for expressing concisely in symbol relationships that are cumbersome to describe in words. Algebraic symbols in the equation stands for the quantities that consist of numbers and units. The number represents measurement, and the measurement is made in terms of some standard. The unit indicates what standard is used. 6. A number to specify a quantity is useless unless we know the unit attached to the number. To make a sari, do we need a length of 5 millimeters, 5 meters, or 5 kilometers? In the term paper due in 3 minutes, 3 days, or 3 weeks. There are not enough letters in the alphabet to assign a unique letter to each quantity. The same letter V can represent volume in one context and voltage in another. Avoid attempting to solve problems by picking equations that seem to have correct letters. A skilled problem solver understands specifically what quantity each symbol in a particular equation represents, can specify correct units for each quantity, and understand the situation to which the equation applies. In the language of physics, the word factor is used frequently, often in a rather idiosyncratic way. If the power emitted by a radio transmitter has doubled, you might say that the power has increased by a factor of 2. If the concentration of the sodium ions in the bloodstream is half of what it was previously, we might say that the concentration has decreased by a factor of 2. Or in blatantly inconsistent way, someone else might say that it has decreased by a factor of 1/2. The factor is the number by which a quantity is multiplied or divided when it is changed from one value to another. In other words, the factor is really a ratio. In the case of the radio transmitter, if P sub O represent the initial power and P represent the power after new equipment is installed, we write P all over P sub O is equal to 2. It is also common to talk about increasing 5% or decreasing 20%. If a quantity increases n%, that is the same as saying that it is multiplied by a factor of 1 plus quantity n all over 100. If a quantity decreases n%, then it is multiplied by a factor of 1 minus the quantity of n over 100. For example, an increase of 5% means something is 1.05 times its original value, and a decrease of 4% means it is 0.96 times the original value. Physicists talk about increasing by some factor because it is often simplifies a problem to think in terms of proportions. When we say that A is proportional to B, we mean that if B increases by some factor, then A must increase by the same factor. In other words, the ratio of two values of B is equal to the ratio of corresponding values of A, expressed as B sub 2 over B sub 1 is equal to A sub 2 over A sub 1. For instance, the circumference of a circle equals 2 pi times the radius C is equal to 2 pi r. Therefore, C is proportional to r. If the radius doubles, the circumference also doubles. The area of a circle is proportional to the square of the radius. The area must increase by the same factor as the radius squared. So if the radius doubles, the area increases by a factor of 2 squared is equal to 4. Proportion A sub 2 over A sub 1 is equal to quantity R sub 2 over R sub 1 squared is equal to 2 squared is equal to 4.